Hi students, welcome back to Amp Academy. In this class, in this video, we will be trying to understand how did we arrive to the formulas of the great thing called sum of zeros and product of zeros, because it's always a question coming in exam from this point of view. The derivation is altogether not important, but as a knowledge point of view, how is it arriving? We need to understand that. Okay, something for curiosity corner for knowledge purpose. From exam point of view, not so much. It's very rare they can ask this in exams. So here we have an equation, ax square plus bx plus c. Technically a polynomial because I'm not going to equate it to 0 right now. Now, if I have this polynomial, you can always factorize it down. No? It's a quadratic polynomial. So if you have a quadratic polynomial, you can factorize it down and assume that the zeros are uh, assuming the zeros are alpha and beta. So this part, I can break it down. So I can write this as the equation a into x minus alpha into x minus beta. Because any quadratic equation, if you can factorize it down, you will get x minus alpha into x minus beta. And a happens to be just a coefficient or a constant which is around. So ax square plus bx plus c can be factorized and you can get in this form. Okay. Now, when you simplify it further, okay, so when you keep the constant aside, so you end up getting a times x into x, which is x square x into minus beta, x minus alpha into x minus alpha x, and minus alpha into minus beta plus alpha beta. So this is what your uh, quadratic polynomial ax square plus bx plus c is becoming. It's just, if you factorize it, you're supposed to get in this form, a times x minus alpha into x minus beta. So this part I'm simplifying further and I'll rearrange the term in the right hand side. So now rearranging the term in the right hand side, I get x square minus common, minus x common actually outside, because both the terms have minus x common. So in the brackets, I'll get alpha plus beta plus alpha beta. So this is where I can derive my formula. I'm going to compare the x square term with x square term and the second part over here, that is x coefficient alpha plus beta with the b value over here. And keep in mind that a is common outside. So if I have to write it in simple form, it will be ax square minus a into alpha plus beta into x plus a into alpha beta. And this is left hand side ax square plus bx plus c. Now I will take down the part, the coefficient of x. I'll equate them. So I can write b is equal to minus a times alpha plus beta. So I get minus b by a is equal to alpha plus beta. This happens to be our first formula, sum of zeros. Okay, this is, I have derived it on the basis of the factor, because every quadratic polynomial will have two linear factors. The factors I have taken x minus alpha and x minus beta, assuming that alpha and beta are the zeros of the polynomial. Now, second part, if you want to do the product part, I'll equate the constant term a into alpha beta with the constant c. C is equal to a into alpha beta. So I'll just take this a, put it across the side. So I get c by a is equal to alpha into beta. This is my second formula for product of zeros. This is how we come to a conclusion that the formulas for sum of zeros and product of zeros are so and so. Thank you.